Fuses are not just about protection, they're also about troubleshoot. The fuse itself tells you something when it blows. A blown fuse is not a problem, it's a symptom. So now, once you get past the 120, we're down to the typical 24 volt DC and lower voltages. And those voltages are completely safe due to the fact that your skin resistance is high enough. You can't generate enough current to hurt you. I only know of one person I know that can actually feel 12 volt from a car battery. He was an auto mechanic and he could feel it. We didn't believe him. We put an ohm meter across his skin and he says, "So what's it say?" I said, "It says you shouldn't work on electricity. Your skin resistance is so low if you can feel 12 volt, we believe you." So that 24 volt DC though, you can't get enough current. You might be able to feel it if you were really sensitive, but it can't possibly hurt you. You can't get enough current to do any damage. So in your control panels, you'll see fuses of various types. And the most common one you see in the control panels is the little glass fuses. That's a 1/4 by 1 1/4. And this is a 5 millimeter by 20 millimeter. And the basic difference between the two fuses, they both have the same voltage rating and so forth. Where the rating differs is a fault interrupting capacity. The 1/4 inch fuse can interrupt a higher amount of current than the little 5 by 20. So that's an issue for, how do you pick fuses? Well, I always use the 1/4 inch on the 120 volt power, and I use the little ones on the 24 volt because this isn't necessary. One of the things is I also like the fact that when I see the fuse in one of my panels, I know that I'm working on 120 and not on 24. So I pop open a fuse holder. Oh, there's a 1/4 in there. This isn't a 24 volt circuit. This is a 120 circuit. And fuses are not just about protection. They're also about troubleshooting. I went to work for a company that built waste treatment plants. And I go out to a job and I find out that the entire 24 volt circuit in the whole plant is on one 24 volt fuse. You say, well, okay, the fuse is carrying it. Yeah, but then the fuse blew. How do you troubleshoot that? There were like 20 sensors around the building that were running on 24 volts. The PLC was on 24 volts. So what's your troubleshooting method? There's only one method. Lift a wire and put a fuse in. If it blows, that's not the wire. And so that's how you're going to troubleshoot. You're going to keep disconnecting things until you get the fuse to stay on, and now you know what circuit you're on. So in panels that I build, you'll always see there's a whole lot of fuses. And the reason is, I don't want to make a trip out to the customer to troubleshoot. I want the customer to say, this isn't working. And I say, check for fuses. Oh yeah, we found a blown fuse. Well, guess what? It only feeds that device and maybe 2 other things. Now you know what to look at. You're done troubleshooting. You already know where you're at. So that's the main value of having lots of fuses. Now, you also can protect sensitive equipment by sizing the fuse appropriately. Like for instance, we typically only use a fuse of about 1 amp on all of the input and output circuits on the PLC, because 1 amp is about twice what the rating is of the outputs and inputs on the PLC. And so that's good enough. And you don't want nuisance tripping, but when you're talking about powering things like sensors, they only draw 10, 20, maybe 100 milliamps would be a lot, which, 1/10 of an amp. And so a 1 amp fuse is adequate. And as I said, I break the circuits down. In the particular PLC we use, I like the fact that the connectors are in groups of 4. There's 4 inputs and a common, 4 inputs and a common. on a single connector, and so I tend to power the 4 with one fuse. And the same thing on the outputs, it's 4 and 1, 4 and 1, and that makes it easy to troubleshoot. You can unplug that connector from the PLC, and if you put your fuse back in and the fault goes away, you know that you're in the right place. So that's how that works. So a big thing about with fuses is troubleshooting. There's another side to it. When you're using the little glass fuses, the fuse itself tells you something when it blows because it's clear. And if you look at the fuse and it's blown, if the fuse tube is black, that means it was a high current fault. In other words, a dead short. That's not an overload. When you see a black fuse, that's something that blew due to a short, okay, or a faulted power supply or something like that. That was not a low current event. When you look at it and the fuse is gone, the element's gone, but there's no blackening, that's an overload condition. The fuse might be too small, the load might be occasionally too large, so that's a different category of problem. So that right there is a big help in troubleshooting why something's not working. So the worst thing that could happen when I used to have electricians was if for them to come back and tell me they found the problem, it was a blown fuse. Well, that would send me right through the roof because a blown fuse is not a problem. It's a symptom. You didn't solve the problem. We're going to get called back. The customer's going to be pissed because we didn't solve the problem. We just changed a fuse, you know. And I've had customers tell me, oh, I could have changed the fuse. Yeah, you're right, you could have. You didn't call me to find out to change the fuse. You called me to find out why the fuse is blowing. That's the important thing. So that's the kind of stuff you look for. Now, in big power fuses, there's nothing to see except that I have in fact seen cases where the fuses on big power fuses, they're usually pure copper. The ends are pure copper. And I have seen them where the pure copper had turned blue. And blue is a sign that it was heating. But fuses don't heat from internal resistance. They heat from a bad connection in the switch they're plugged into, or that the knife blades on the switch are heating up. So that blue, seeing a pile of fuses and you find one that's blue, oh, we've got a problem, but it's not an overload problem, and it's not a short. It's heat damaging the fuse, which is another issue. So for the flat bladed fuses, the large power fuses, they even make what they call fuse tighteners. They're like a little C-clamp, except that they have like a black knob on the outside. And the purpose of them is that when you have problems with the fuses melting out, you put this little C-clamp on and you tighten it up. It's insulated. You tighten it up to hold the blades tight. And you can even use them on some of the knife switches. You can clamp the switch closed that way. But we used to have piles of them around. It was a popular thing to do. Things have gotten, I don't know if they still use them. I haven't seen an installation like that where I came across those. But that is a big problem, the fuse melting out due to poor contact. So all of those things are, troubleshooting stuff that you look for when you're trying to figure out why something isn't working. And blue fuses, fuses that have smoke, fuses that are just gone, are all different symptoms of a problem. So in the case of like a PLC where you see the fuse melted out and it's feeding, say, some sensors, you probably have a fuse that's a little too small, unless you put a new fuse in and it blows again, and then maybe you have a sensor that's drawing more current than it should. But that's fairly easy to troubleshoot.